Hello and welcome back to computer programming. So today is going to be our first day at looking at loops in any sort of like structured way. Now you've already seen loops in a couple of the programs that we've written, right? In making change, we used a loop as like an error check, and we wouldn't let them go on until they typed in a valid value. We used a loop inside of our function calculator so that they could keep doing additional calculations. You used a loop inside of your day of the week program so that they could put in multiple dates. So we've already seen that loops are sort of a way to repeat code over and over and over again. And today we're going to be looking at something called the for loop. And we're going to see how they're sort of structured and why they're valuable and the ways that we can use them. All right, so as usual, you're going to want to start by downloading your file. So click on this, open a new window, hit my download button. All right, head over to my downloads folder, extract all, click extract. Again, I like to keep things neat, so I'm going to X this out. I'm going to delete the zipped version because I don't need it anymore. I'm going to drag this into my computer programming folder. And look at this beautiful folder that just has everything we've done so far. Nice, neat, organized, easy to find things. All right, so Loop Lab, for loops. Click on the project file, and then let's see what we've got. All right. So there's a whole bunch of code in here, and we're about to talk through it, and we're going to kind of see what's involved with each of these things here. But we'll start just by running it and seeing what happens. All right, so if I hit run, I'm going to get a virus and threat protection. But we see loops are fun, and then we see loop counter value is 10, 9, 8, 7, 4, 6, 3, 2, 1, blast off. Want to see me count to 10? Rats, I didn't make it. How many stars do you want printed? Let's get 1,000. All right, so there's 1,000 stars. So clearly there's like a lot of repetition going on in here. Now, how does that repetition happen? What's the structure? What are we actually going to be doing today? All right, so let's take a look at the code. So the very first thing that we have here is our very first for loop. And you'll notice it says every for loop has three parts: a starting value, a test, an increment or decrement, and then the code inside the loop keeps running until the test is no longer true. All right, so here's our for loop. All right, let's talk about syntax for a little bit. It's for, all lowercase. We have this left and right parenthesis. Notice there's no semicolon at the end of that parenthesis. Then we have braces. And then inside of those braces, we have some line of code. All right, so what's going on in here? All right, this right here, X, is what's called our loop variable or our loop counter. So the very first thing that we do is we give that variable a starting value. So this is saying, hey, X equals 1. All right. Next, we have a test. And this test is going to control how long our loop runs. So what this is saying is, hey, this loop keeps going as long as X is less than or equal to 3. When this is no longer true, our loop is going to stop. The last part tells us how our loop changes or how our loop variable changes. And this is basically saying, hey, every time the loop runs, make X get 1 bigger. And notice that this last part does not have a semicolon, and it shouldn't have a semicolon. So you don't want to put one in there. That will cause a problem. So what's actually happening when your code executes? All right, so we have our two variables that we created. Those are fine. We get to the loop. X gets the value 1 and put in it. All right, so this is the very first thing that happens. X gets set to 1. The second thing that happens is this test is checked. All right, we start to make sure that this is true. So it's going to do 1. Is it less than or equal to 3? Right? That is true. So then we get to go inside of the loop and actually run this code. Now this brace marks the end of the loop. So after I run this code, I then go up and do my increment or decrement. So this is actually sort of the fourth thing in line. The first thing is this. The second thing is this. The third is the code inside the actual loop. Once that finishes, then we do the increment, and our variable becomes 2. All right, so this changes our variable to 2. We then go back and do the test, and we say, all right, is 2 less than or equal to 3? All right, that's still true. So we print out loops are fun. Then we go back up and we do the increment again. So now we're doing 2 plus 1, and we're getting 3. All right, we then check our test, and we say, all right, 3 is still less than or equal to 3. So we get to run the loop again, and we print out loops are fun. Then we go back up here. We do the increment. X becomes 4. We then check our test. 4 less than or equal to 3 is false. When that's false, the loop is over. We don't do this one last time. We skip over this and continue on to the rest of our program. All right, so when the loop is finished, X has a 4 in it because that's what made this no longer true. And then we get to continue on with the rest of our program. So that's why when we ran the output here, you saw loops are fun get printed out 3 times. All right, X was 1, which was made this true, so we printed it out. X then went to 2. This is still true, so we printed it out. X then went to 3. This was still true, so we printed it out. Last but not least, X went up to 4. This part was no longer true, so the loop ended, and we skipped down to this line right here. All right, so that's the general structure. You always give your variable a starting value, you give it a test, you tell it how it's increasing or decreasing, and then you have some sort of code that repeats. All right, so if we look down here, it's just more for loops, but it's showing you different ways that you can write it. So here I have a loop that's starting at 10. I'm saying keep going as long as this variable is less than or equal to 50. And this is shorthand, all right? This is shorthand because loops are so common. There's like little shorthand you can use. And this is the same as you saying x equals x plus 5, right? Those mean the same exact thing. Whether you write x equals x plus 5 or you write it as x plus equals 5, those mean the same thing. This is just shorthand because it's something that gets done so often in programming. And in fact, you can use this anywhere in a program. It doesn't just have to be inside of a loop. It just means make your variable 5 higher. So again, if we look at our output, x starts at 10. 10 is less than or equal to 50. So we run this code and print out the 10. Then it goes up to 15, which still makes this true. We print it out. It goes up to 20, still true, so on and so forth. Eventually, this gets up to 50, still true, so we print it out. It then goes to 55. This is no longer true, so we continue on with the rest of our program. All right. Now, loops don't only have to go up. You can also count down. So here's an example of I'm starting my loop at 50. Instead of doing less than or equal to, I'm doing greater than or equal to. Because remember, the loop keeps going as long as this is true. So if I actually had this, it would be, okay, x equals 50. Is 50 less than or equal to 10? Nope. And we would skip the entire loop. We'd never actually get to do any code whatsoever because this test is false at the very beginning. So a lot of times kids goof that up, but when you're going down, it's generally greater than or equal to 10. And then this is the same shorthand that we saw up above. All right, so it's not just that it works with addition, it can also work with subtraction, multiplication, and so on and so forth. So this is just showing it with subtraction, and this basically means take away 5 from x each time. So if we look at our output, we've got 50, which is where we started, and then it goes down to 45, 35, 30, 25, 20, 15, 10. Eventually, x is going to go down to 5. 5 is not greater than or equal to 10, and the loop is going to stop. So just remember that even though this says x is greater than or equal to 10, when the loop is actually over, x has a 5 in it because it did this subtraction. That's what made this middle part no longer true and allowed the loop to actually end. All right. Now, one thing I want to warn you about, because this is a mistake I see a lot, is kids sometimes just write x minus 5. X minus 5 will not work, all right, because you're not actually changing the variable x. All right. You either have to write x equals x minus 5 so that the value of x is actually changed, or you have to use the shorthand where you say x minus equals 5. All right. But a lot of times kids just write x minus 5 or x plus 5, and that doesn't actually change the value of x. You know, it might do the calculation, but then that answer just kind of disappears into thin air. Unless you write x equals something or this shorthand, it's not actually going to change the value of x. All right. Now, another thing is I created my variable x up top here. You can also create the variable right inside of the function, right inside of the for loop. So I could create I inside of the for loop if I know that I'm only using this variable inside of the loop and I don't need it anyplace else. I can say I equals 10, I greater than or equal to 1. And then this is just another shorthand. All right. Subtracting by 1 or adding by 1 is so common that they don't even want to have to type I minus equals 1. They got even lazier and just came up with I minus minus, which just brings your variable down by 1. Shockingly, not shockingly, I plus plus would bring it up by 1. So again, this is just saying my variable starts at 10. Keep going as long as it's greater than or equal to 1. So we start printing things out, and then each time make it 1 smaller. So I would go down by 1. We'd go from there. I would go down by 1. We'd go from there. And that's why you're seeing this 10, 8, 9, 6, 5, 10, 8, 9, 7, 6, 5, 4, 3, 2, 1 blast off. We just keep going down by 1. All right, that's what that I minus minus is. But otherwise, the loop is exactly the same as any of the other ones. Now, a note about creating your variable inside of the loop. All right, it's fine to do that, but you have to recognize that variables have scope. And we've talked about this with functions. Like if you create a variable inside of a function, it only exists inside of that function, right? If you create a variable inside of your loop header up here, it only exists inside of the loop. So if I tried to print out I down here, this would actually cause an error. So like if I tried to compile this, all right, my code would not compile because I doesn't exist outside of the loop. It only exists inside of the loop where we created it. Now, one thing that you want to be aware of when you're doing these, because this is a mistake kids make a lot, is whether or not you start your loop at 0 and whether or not you start your loop at 1, and then whether or not you use less than or equal to. So if I have this loop right here that starts at 0 and goes to less than 10, let's actually look at the output. That prints out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So this is giving me 10 numbers, but they're going to go from 0 to 9. I'm not actually going to ever get up to 10 inside of my loop. Now, when the loop is over, Z has a 10 in it because what happened is I went from 0 to 1 to 3 to 4 to 5 to 6 to 7, 8 to 9. 9 was less than 10, so I got to print it out. Then Z went up to 10. This was no longer true, and the loop ended. So if I had a second cout statement here after the loop was over, that would print out 10. But inside the loop, I'm only going from 0 to 9. So if you want your loop to run 10 times, there's usually 2 ways of doing it. You're either going from 0 to less than 10, or you're going from 1 to less than or equal to 10. All right, where kids get themselves in trouble is they write 1 to less than 10, and then it's only running 9 times. Or they write 0 less than or equal to 10, and then it's actually running 11 times. So you just have to be careful that you kind of keep those straight. And remember that if you start at 0, generally you're going to less than the number if you want it to run 10 times. If you start at 1, you're generally going less than or equal to if you want something to run 10 times. And again, depending on what you're doing, it might not matter whether you start at 0 or 1, but then there's going to be stuff that we do later where it's actually going to be important that we start at 0. So I like to get in the habit of starting at 0 because it's going to be useful later on when we start dealing with arrays. But again, just something to kind of keep in mind with these loops and when you're trying to get it to run a specific amount of times. All right. Now, last but not least, you can start mixing and matching variables inside of your loop. All right, so here I asked, how many stars do you want printed? I read that into a variable. And then when I printed it out, I used that variable inside of my loop. So, I started this at 1. I did my less than or equal to. And then this is the value that was provided by the user. So I can start using variables inside of here to make my loops more flexible. I don't have to like hard code in that I want it to run exactly 10 times or I want it to run exactly 20 times. I can gather input from the user and then use that input as part of my loop so that I can get 1,000 stars or 2,000 stars or 1,000,000 stars. 1,000,000 takes a while, but you could get 1,000,000 stars if you wanted to, because it's just repeating that code over and over and over again. All right, so this is going to be sort of the next thing that we look at is setting up these loops and using them to sort of repeat things over and over and over again. Because remember, computers don't do big complicated things. They do really small things at high speeds. So we're going to do all sorts of calculations that we're going to let the computer do them, and we're going to have them do it in sort of this long, tedious way, but it's going to do it so quickly that we're going to get our answers sort of instantaneously. All right, so there's one example I'm going to do together with you, and then you're going to try some of these on your own. All right, so what I'm going to do is I'm going to comment out all this code so that it's there for you to look back at, but it won't actually run the next time we run our program. So I went right above my int x, I did a /, I did a star, and then I'm going right above or right below that last cout statement, but above the system pause, I'm doing a star /. All right, so what we're actually going to do here is we're going to use a loop to write a little program that's going to multiply all of the numbers from 1 to 10. So it's going to do 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. All right, and that's actually in math what we call a factorial. So that would be 10 factorial. And the answer that we should get, I think if I remember correctly, well, who knows? I'll check it once we actually get our answer here. I've got a calculator here. Let's see what we get. Math, probability, 10 factorial. We're going to get about like 3 million. All right, so 10 factorial, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 1 is about 3 million. But we're going to write a little program that calculates this for us. All right, so first thing we're going to do is we're going to start with our loop variable. So I'm just going to use I again. All right, and I can use I because I commented on all that other code, so it's fine. And then I'm going to make my loop, and I'm going to say for, and I need a starting value, so I'm going to start it at 1, and I've got my semicolon, and I want to multiply all the numbers from 1 to 10. So I'm going to go I less than or equal to 10. Because remember, if I do less than, I won't actually get 10. It'll shut off right before I get to 10. And then I'm going to do I plus plus. All right. I could also write this as I equals I plus 1. That means the same exact thing. Or I could write it as I plus equals 1. Also means the same exact thing. But I'm going to go with I plus plus. No semicolon at the end here. And then I've got my braces. So inside the loop is where I'm actually going to be doing this multiplication. And if I'm doing multiplication, I need a variable to sort of keep track of my answer. So I'm going to go up here and I'm going to make another variable called product. Now, whenever I'm doing calculations, I have to be really careful because if I don't give this a starting value, I have no idea what's being stored inside of product. It might be a 0, it might be a 1, it might be a negative 52,000. I have no way of knowing what's actually stored in this variable when my program runs. So generally, we're going to have to give it a starting value. Now, when we're adding numbers, we usually make the starting value 0, all right? Because if you're adding numbers, you want to start with 0 and then go up from there. When we're multiplying numbers, we're not going to start with 0, because if we started with 0, we would do 0 times 1, and then it would be 0. And then we would do 0 times 2, and it would be 0. And we would do 0 times 3, and it would be 0, and we never get anywhere. So instead, when we're multiplying, we usually start at 1. All right, so I've got this loop variable. It's going to go from 1 to 10. And I've got this variable product where I'm going to actually do and use the calculation. So inside the loop, here's where my calculation is. So product equals product, which is saying take the old value of product, multiply it by, and then I'm going to multiply it by my loop variable, because that gets 1 bigger each time, and store that as the new value inside of product. So if we think about this, the very first time, I is going to be 1. So it's going to do 1 times 1 and save that inside of product. All right, the next time through the loop, I is going to become 2. So it's going to do 1 times 2 and then store 2 inside of product. All right, then the loop variable is going to go to 3. Product now has a 2 inside of it, so it's going to do 2 times 3 and store a 6 inside of here. All right, then we loop back up. The loop variable goes up to 4. Product is now 6, so it's going to do 6 times 4 and store a 24 in here. All right, then it's going to do 24 times 5. 24 times 5 would be like 120, 120 times 6, and so on and so forth until eventually I get to 10. All right, so that's kind of the idea of what's happening here. All right, this keeps going up by 1, and I just keep multiplying it by the same thing over and over and over again to get my final answer. All right, now I don't want to put my cout statement in here, because then it'll keep printing it out over and over and over again. I just want it to print out the final answer. So when my loop is over, then I can print out my answer. I can say cout, and I'll just say 10 factorial is, I'm going to close my quotes. I'm going to do less than, and I'm going to print out my product variable. Then I'll do less than, end L, just for formatting purposes. All right. So if I run this, let's see how we did. All right, remember we're hoping to get like 3,628,800. And that's exactly what we got. 10 factorial is 3,628,800. All right, so this is the type of thing that you're going to be doing inside of the lab. All right, so let's take a look at the actual lab document so that you can see exactly what this involves. All right, so here's the lab document. All right, there's going to be 3 exercises that you're doing. All right, those 3 exercises you can just put right below this example we just did together. So you don't have to create functions, you don't have to separate them out, just put the next one in right here. After you finish that one, put the next one in after that. You can just go straight down and have them all inside of your main. So the first one is find the sum of all the numbers 1 to 500. So very similar to what we just did, all right, except instead of going from 1 to 10, you're going from 1 to 500. Instead of multiplying, you're going to be adding. Otherwise, very similar. All right. The second one is another calculation, but instead of just adding numbers, you're going to be adding the squares of numbers. So instead of 1 plus 2 plus 3, it'll be like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. You're going to be doing a second calculation where you add up all the numbers and then square them at the end. and then you're going to subtract those two. So basically, it's like a series of calculations that you're going to go through to find your ending answer. Now, a couple of things that I want to just point out is technically you only need one loop to do this because both calculations are going to go from 1 to 100, I believe. Find the difference for the first 100. So yeah, all of the both calculations are going to go from 1 to 100. So you can do both calculations inside of the loop. It's just one is you're adding the squares, one you're adding just the regular numbers and squaring it after the loop is over. Now, caret, like you're used to using in algebra or your calculator, does not work. So when you're squaring, you're just going to do like x times x or, sum times sum, whatever your variables are, but you're not actually going to be using the caret. That is not a command that's going to do what you think it's going to do in C++. Okay. The third one here, the third activity is using a for loop to try to determine if a number is prime. All right, so a number is prime when it's only divisible by 1 and itself. So basically, you're going to use the loop to keep dividing the number and see which ones go in evenly. All right, and to see if things go in evenly, we're going to be using that remainder operator that we've used so frequently for things like even and odd, leap years, and so on and so forth. So these are the 3 required. And then there's a 4th bonus exercise that you can choose to do, which is all about trying to create the Fibonacci sequence with a loop and then adding up certain terms inside of it. All right, so each one is just kind of like a little puzzle, a little calculation that you're going to be solving or trying to solve via loops. Now, with the assignment, because it's going to be probably pretty useful for this one, you're going to note that there is a picture here that shows the answers. So if you want to make sure that you're getting it right, the answer to the first one is this number right here. The answer to the second one is this value right here. This is the answer to the bonus. So if you want to know whether you got the bonus correct, this is the answer you should be getting. And then the last part is just going to be, you're going to be entering a number, and then your program should either say your number is prime or your number is not prime. All right, so that's what's involved with this one. Obviously, if you have any questions, let me know. Otherwise, feel free to get started, and best of luck. All right, bye.